Okay. Yeah, okay, that's fine. So as per the last session, so we have completed all these concepts, including HDFS. So I think you all are okay with these things, right? You have done a little bit of practice, or you got the knowledge regarding all these points. If you have any doubts still now, just you can ask me, or else we can move to the next processing area, MapReduce and other things. Okay, can we move to next one, or do you have anything? Okay. Yeah, we'll see just a overview of MapReduce of exactly it. Yeah, who joined? It's Sai. Yeah, okay.
Yes, Satish.
Yeah, I say just starting now only. Just we are starting MapReduce. Sai, do you have any doubts on these things as per past sessions?
Right now, no, Satish. I'll go through a bit and
Okay.
then.
Yeah, okay, fine, Sai. Whenever you are getting any doubt, just let me know.
Okay.
So yeah, as of now, we have discussed the things like how to get the data from the different sources to HDFS. Basically, any project, if you take big data or any related project, HDFS is common for storing the data. Okay, whatever. So HDFS is common. So as of now, we have stored the data by using -put command from the different sources. It can be a local machine or file or text file or whatever the file, but by using Hadoop commands, so we are able to store the data. Once you store the data, the particular file, what is the next process? We need to execute this data. We need to process this data based on our requirement, right? So this is the raw data. From this raw data, we need to process it or execute it, and we'll get the result and store it here. The main advantage as per the Hadoop features, data will not be moved anywhere. Data will be executed here itself, where data is resides, where data is stores. That means which data node. Out of 4,000 data nodes, data will be there in the particular node. Sorry. So data is not going to move anywhere. Just the process will execute here itself with the help of MapReduce programming. Okay. So now we will use the MapReduce programming, MR MapReduce, to process it in a different way. So this is the MapReduce overview. Actually, MapReduce will take the input from the HDFS only. It will not take input from different other machines. It will take input from HDFS blocks. If you see, these all are the blocks, data blocks. Okay. Here there are almost 6-7 blocks of data is there, but all 7 blocks are one particular file or one particular data set. So when you are processing, here MapReduce is again two parts. One is map part and a reduce part, like this. First map part will be executing here. M means map part. Once I will tell you what exactly map and how it will work. Uh, Once map is completed, the data will be coming to the intermediate area. Can be called as the intermediate area. Once it is gathered into the intermediate area, data will be grouped. Grouping will happen with the help of key and value combination. If you know collections, maybe in Java or C++, collections, you know, right? Key and value, map function, map is there, right? In collections, list map, like that. So the key in the key value format, it will retrieve the data and it will group with the help of key value only. After that, it will execute the reduce part, second part of the map reduce. Reduce part will execute. Then the final output will be coming to outside and to the HDFS again. Okay. There are two tasks. One is the map task and reduce task. Just I'm opening this viewer. So here we'll see the MapReduce. Now today in the next hour we will discuss what exactly the MapReduce job. Okay, and what is the mapper and what is the reducer. Okay. Basically, MapReduce is again one more framework within the Hadoop or within the big data area. Again, within the along with HDFS, MapReduce is one of the programming paradigm which will be working for processing the data. Okay, the data should be available within HDFS, not from the other systems. Okay, the MapReduce will execute in a distributed manner. The map and reduce will execute distributed manner across the several machines. That means across the cluster or network. Basically, the MapReduce framework or process will have typically 5 pages. Okay, generally, we discuss with 2 pages, map and reduce, but internally it is having 5 phases. One is the map phase, last one is the reduce phase. As a programmer, we need to involve into these two, map and reduce, not in all 5 phases, until unless if you are doing any customized things. Okay, so once map is completed, next the partition will be happening. After that, sorting and shuffling will happen, then reduce. Okay, so here a single map task would works typically on block of data. You know block of data, right? By default, what is the default block size? Anybody? Which we have, yeah, 64 MB. Yeah, so generally, but when we are when the program is taking, you will check the block size in HDFS and cited XML. Based on that, if it is a 64 MB, then it will take 64 MB, or else it will 128 MB, it will take 128 MB as a block. On top of that block, the map task will execute. Map task will work. So then, how many map tasks will be there? If the data is having 10 blocks, then 10 map tasks will execute. Right? Because of the block task, not irrespective of the size of the data. If it is 256 MB, then maybe one block only will execute, one mapper. If it is 64 MB, there will be 4 map tasks will execute. So that is the reason we are talking typically on block of data based on this size. And after all map task is completed, then only the reduce task will be starting. Let me put it here in an example. Suppose we have a data set like product.txt is a data. It is having just approximately 200 MB file. Okay. So now already first we need to copy into the HDFS side. So data is copied into HDFS first of all. This is HDFS. So here data is copied into the HDFS in the form of 4 blocks. Okay, this is the one block. Block also this is the data nodes. This is another data node. This is another data node. Another data. There are more than 10-20 data nodes are there. But first of data is copied into HDFS. This is the HDFS. When it is copied to HDFS, then it is split into 64 MB, 64 MB, 64 MB, and the remaining 20 plus MB is here. So when you are executing Mapreduce program, then now Mapreduce, MR means a smart short form of Mapreduce, then it will start. Okay. So Mapreduce, first, what is the first phase of Mapreduce? Map, right? Last is reduce. In between, partitioning, sorting, and shuffling will be there. So when we are starting with the map task here, first map task will be here. It will execute. Now there are 4 blocks of data is there which is belongs to product.txt. Then 4 maps will start. 4 maps will start. So once map is completed, just a moment. Sorry. So 4 mappers will execute. Basically, the all mappers will execute on top of HDFS. On top of data node only. Here itself only it will execute. Here itself only the mapper will execute. All 4 mappers will execute here. So that means data is not copying to Mapreduce area or something else. Everything is almost same like this. Okay, execute. Once all 4 executed, then the output of the data is coming to intermediate area. Output. So this is called intermediate area. So map 1, map 2, these are the mappers. Map 1, map 2, map 3, map 4. Once data is coming to intermediate area, it's a little bit lengthy process. Just try to understand. It will take 2 to 3 hours time to explain complete Mapreduce, but it's very important even in interviews or at the time of working also. Mapreduce and ARM concepts. Okay, now it will be coming to intermediate area. When it is coming to intermediate area, so when it is coming to intermediate area here, 2 things will happen. One is that by default the partition will be taken care. In Mapreduce, by default it is working with the hash partition. Hash partition is the default partition. If you don't do anything, by default it will be working. It will be taken care of with the hash partition here. So that means data how you want to make partitions. And what is the next step? Sorting and shuffling. Once the data which is coming here, this data will be sorted in a sorted manner. You know sorting technique, right? Ascending, descending, like that, it will be sorted. Once the data is sorted in a proper manner, then after that, shuffling will be started. Shuffle will be done. In the shuffling, what will happen? It will be arrange the data in a grouping manner. Same set of data will be, it's a product, right? If you want to group it, yeah, laptops related product data here, and mobile data here, and maybe other electronics data, like maybe shoes data, like that. Each product data will be divided into set of groups, like that. This data blocks or data, not a data, it's just a grouping the data here. Internally it will happen. Okay, here data will be copied from here to here once complete the mappers. All mappers are completed, then only the partition, sorting, shuffling will start. Until unless it will wait for completing the all mappers. Okay. Then it will execute the register part here. Now register. At any point of time, only one register will work in the Mapreduce program. Irrespective of the map. Mappers are 4, right? It can be 4 or 40 or 400, doesn't matter. But only one register will work at any point of time. 4 mappers and one register. Okay? One register will work here. Once the register is completed, the final output data will be coming to again HDFS and storing in some any other machine, maybe here or somewhere else. Again, it will store in HDFS. It will not store into the other file system or any local system database. It will directly store into HDFS. If the output is also more than 64 MB, then it will store into 2 blocks, into 2 machines maybe. If it is only less than 64 MB, it will be in 1 block, 1 machine. Okay. So this is just a high-level overview of the Mapreduce program.
What exactly happens with the partitioning?
Yeah, partitioning will be taking care of the partition, and I'll tell you a small example. Suppose we are working with the people data from one particular state. You can take New Jersey state. I want to know. I got the data, complete raw data about the people or maybe order list or something else. So once I get the data, I want to process this and I want to store into the data in a 3 different partitions. Complete citizen data. So I want to store the data into here. The age less than 18 people into one partition, and 18 to 50 into one partition. I want to get the greater than 50 years old people data into one partition. If I want to get like this, then I need to implement the partition, then data output. Once we are processing area, then output will be storing into 3 different files, irrespective of the size. If it is more than 64 MB, then only we are storing into different blocks, right? But even less than 64 also, based on the age, we are splitting the data. That means we are partitioning the data into different blocks. Or maybe your requirement may be male data into one block and female data into one block. Then you are partitioning into 2 blocks here, 2 partitions, like that. Okay. If you don't apply any partitioning, but still it will do the partitioning based on the hash partition. I'll tell you what is hash partition once we complete that one complete process. Then you will understand more.
Yeah.
As of now, you got it, right?
Yeah, and this intermediate area is on another node.
Yeah, in another node. It can be any node which is having the space. On fly, it will decide.
Okay.
On the fly. Only mapper data is executing is the same node, but after that intermediate execution and reduced execution will be on some other node which is available in within the cluster again.
Okay, and once the reducer, it's again, what is this blue line going to those data nodes, Satish?
Yeah, again output. What is the output I'm getting? Again, it will store into the HDFS only.
Okay.
This output. Here, blue line. Okay, because of why I'm again putting it here, that means data, if I put like this, then you may think this is something else. It can be a NoSQL reporting tool or any database. No, not like that. Again, it will store it to the only HDFS only. Okay? Yeah. Sharon, Satish, Janigram, any questions from your end? You can ask any question, no issue. No need to worry about it. Okay. So this is just a high level overview. We'll see some of the other points in MapReduce. So now here what exactly the job? MapReduce job. Job means it's a complete execution of mapper and reducer over the entire data set. Then we can call it as a job. Okay. Execution of mapper and reducers. Here in our example, that this is the one of the completed data, complete one. From here to and executing here, and I am again coming back to data set to here. This is one complete one process. Here in this process, you can see there are 5 mappers are there and 1 registers are there. Total 5 tasks. This is now job is having 5 tasks, right? Yeah. This what is task? Task is a single unit of execution. It can be a map or it can be reduce. Here we have 4 mappers and 1 reducer task. Total 5 tasks. All these 5 tasks comes under one job. Okay. The terminology should be used job and a task like that. We will not use a process like that. Use a job. Completion execution of mapper and reducer on one entire data set. Here also we have worked on single data set called product.txt data set. Okay. And here the task is single unit. The map task executes typically over the block of data as we discussed. Whatever the data block is there, only that data it will work. And registers work on mapper output. Again, there is no specific size here. If mappers is producing out of 204 blocks, it may be 50 MB or it may be 150 MB, it may be something else. It may be sometimes complete to one out of 200, it can be 195 MB also, maybe output from the mappers. So again, the reducer will work on top of complete output of the mappers. Okay. Here, one more thing is a task attempt. What is the task attempting? Okay. So here, the attempt is it will create one instance to execute the task on top of the block of data. It can be a map or it can be reduced task. Just creating an instance and attempting to execute it. So suppose sometimes if task is failed, okay, on particular partition of portion of data or particular block of data, then all other tasks will complete it successfully. Then what will happen? Okay, here there are 4 blocks are there. So this is completed successfully, this is completed successfully, but somewhere one block these are completed, but this block is failed. This is success. Then what will happen? As per our previous points, once all mappers completed, then only it will start intermediate area or whatever the partitioning, shuffling, sorting, reducer, right? So, but this is failed. Then should we execute complete job again, or any way to minimize the processing again the job?
Rerun that particular.
Yeah, you are running this, rerunning this particular task. So as a developer or maybe architect, we need not do this one. There is an option called task attempt. Task attempt is a feature, or it's a it can be a configurable one. So when it is failed, the particular task again it will retry one more time. Again it will retry one more time, like that. It will try to execute the task 4 times again and again, irrespective of the successful completed tasks. Okay, just a moment. Yeah, sorry, got a call. So once a task is failed, then it will reattempt the task again and again 4 times. Okay, and out of 4 times, it will make sure to attempt the same task in running in different machine. Okay, so here when this is failed, again it will try to reattempt the task one more time. It is first failed, right? Again it will try one more time, and again second time, third time, fourth time. Like that it will try 4 times. If it is second time is if it is success, then no issue. It will process further. Or third time also it will try to execute the fourth time also. If it's fourth time is success, then it will be good. Out of 4 times, first time it is failed, right? Next out of 3 times, it will try to execute the same block of data in another machine. Another machine in the sense, right? The data will be replicated into 3 different blocks, replication. So that means the same block of data will be there in the cluster in some other machine. Maybe one more machine is here. Out of this cluster, this here also the same block of data is there. Then out of 4 times, it will try to execute in this machine. Because of sometimes maybe there may be problem with this machine hardware. Maybe RAM is not supporting, maybe data is not, the software, perfect software jars are not available. Maybe there may be many reasons which is related to hardware or particular data. No, that is the reason the framework itself will execute the data in block of data in other machine. Okay, got it? Out of 4 times, when it is, if it is success one any time, then it will process further, or else then only it will completely fail the job. Okay, so this can be a configurable one. You can open mapred-default.xml. Right, this is a Mapreduce. Basically, everything will be configured in mapred-stated.xml. Even if you open mapred-default.xml with the task attempt, right? We'll see task. See here, mapreduce.map.max attempts is 4 by default. Okay, that's the reason we are talking about. It will execute again and again 4 times. If any task is failed out of, maybe there may be 100 tasks are there. Out of 100 tasks, 99 completed successfully, one is failed. Then because of one, if you run complete job again you need to run 99 jobs, 99 tasks again. It's a waste of time, waste of effort, right? That is the reason at least we will try this particular one 4 times. But in your application project, 4 times is not good. If you want to try again 10 times or 15 times, then simply you can add this particular property in the mapred-cited.xml just to change into 10 number. That's it. By default, it will, from now onwards, it will try 10 times when any task is fails. For map or reduce separate. This is the map-max attempts and reduce.max attempt. Okay, everything is configurable in Hadoop. Just I'm giving this URL in chat. Okay, clear? Yeah, here you can see this one. How many tasks can run on portion of data? Maximum is 4, configurable one. But if you want, you can change these two properties in the mapred-cited.xml. Okay. And here what is failed task, what is killed task. I will tell you what is speculative execution. Failed task is just due to some problem, this is data is not able to execute, our system is not supporting, so this is data is failed. That means we can call it as a failed. Task can be failed due to the exception, any exception, maybe arithmetical exception or mathematical, some out of memory, any can be, or it can be a machine failures also. Machine also maybe get some problem. Because of these things, the task can be failed, right? So when it is failed, the failed task will be reattempted again and again 4 times by default. But what is killed task? Killed task is not exactly like this. If the task is failed 4 times, then task is killed and entire job will be fails. Got it? 4 times we are trying, right? Even fourth time also it is failed, then the Mapreduce framework will not try again. It will kill the task. Okay, it will kill the task and the entire job will be failed in this situation. Even now 99 is completed, 1 is failed, but this is complete one job. Okay, when we are completing 99%, 1% is failed, that means job is fails only, it will not success. Until unless 100% success, then only we can consider it as a successful job, or else it's a failed job. This particular one, if it will try 4 times, then it will kill the job, kill the task, and it will fail the job. Entire job will be fails. Okay. So next, what is the speculative? Speculative execution is a one process which is important one. Just note down the points. This thing. So suppose here I'm taking one more example. This is the Mapreduce process. So you know this is a cluster, right? There are many machines are there. Just there are 4 machines. Can take one more. So what is the machine? This name? This is data node, right? Sharon, can you talk? Can you tell me the names of this machine?
That is master.
Yeah, master in Hadoop, how can we call it as?
Name node.
Name node, right? Yeah, name node. So these are the data nodes, right?
Yeah.
Data nodes. So when we are coming to Mapreduce, what are the 2 processes?
Map and reduce.
Yeah, map and reduce, but in terms of cluster, 5 daemon services are there, right?
Yeah.
We have 5 services. Yeah. One is the name node, data node, secondary name node, job tracker.
Task tracker.
Exactly. Task tracker. So where is the job tracker here in the cluster?
Job tracker is in Mapreduce. Data node.
Yeah, Mapreduce, which machine? Which
Data
machine?
node.
Yeah, job tracker will be there. No, job tracker will be there in the
Okay,
name
okay,
node.
name node.
Yes. So here job tracker will be there. And where is the task tracker?
Data node.
Task tracker will be there on all the data nodes, right? Task tracker. Here, all 5 data nodes will have the task trackers. Okay, all the task trackers are there. So in the same way, how we have discussed in the hardware signal from the data node to name node, right?
Yeah.
In the same way, task tracker to job tracker, hardware signal will be there. It will send the communication to the job tracker. Job tracker will create the job and it will divide the tasks and assign into the task trackers. So suppose the data is there in this particular this block and this block. There are only 2 blocks of data is there, one particular job. Then this job tracker will assign the task to this job tracker to execute such a process, and this will assign to this one. Once it is completed, then it will send the hardware signal back to job tracker, like this. The communication will happen between job tracker and task tracker in the same way how name node and data node will communicate with the hardware signal. Okay. So now what is the speculative execution here? Speculative execution is the execution process. By default it will be in off. We can make it is on by changing the property. So suppose when we are executing the one particular block of data, so this block of data is here. Suppose there are 100 machines are there. Let's take 100 data nodes. 100 data nodes are there. Next. So now 50 blocks are executing here. 50 tasks are executing here. Total tasks 50 within a one job. Okay. So as we discussed, 49 completed successfully, but one is executing, not failed. Still executing. Then how much time we need to wait for one particular task? Okay. We cannot say how much time it will take. Sometimes it may take 1 minute, sometimes it will take 1 second also, right? Then how much time can we wait? Any idea? So if it is failed, then we simply will reattempt 4 times. So even 4th time also failed, then we will fail the job and we will rerun the job. That's simple. We will get some conclusion. But here one particular task is still running. In this case, so then speculative execution is working. Suppose then what will happen here? This is the almost all 50 partner is completed. This is the block is not completed. It is still executing. Okay. Then when exactly speculative execution is start? Speculative execution is nothing but suppose this job tracker is thinking this particular task is running long time. Then this job tracker will execute the same block of data in another machine. Do you remember the same block of data will be there in 3 machines, right? 3 replication. This one is here and this one is here. Suppose let's take one more block here. That means this is the data node 1, 2, 3, 4. Fourth data node is working, but it is still working, not completed execution. Then speculative execution, what will happen? It will start the same execution in the another machine also. Okay, and this process will continue. This will not stop. This will continue. Again, it will do the duplicate execution in another machine, which is duplicated data. Got it? So then what will happen here? Then job tracker will wait for which one will complete first. Then it will take that data and the remaining second one will be killed by job tracker. Okay. Then how job tracker will decide this is not executing properly? Then it has to start one more process parallelly. How job tracker will know? The communication, right? Task tracker to job tracker communication. So in task tracker, it will send the data to job tracker based on the task. How many tasks are executing properly? How many completed? How many still executing? And how much percentage is executed as of now? That is also will send. In first every 3 seconds it will send, right? First task tracker will send this particular task is running properly. It is completed 12% of the task. After that, in the next heartbeat signal, obviously it will be some 20-25%, right? Correct?
Yeah.
And then next time also it will send some 30-40. But here it is sending again 25% only because of it is still executing, right? Again, third time also, if it is sending same percentage of completion, then job tracker will decide there is some problem with this particular task. So then better to start one more task on top of same block of data. Again, it will parallel, it will start, it will not stop, it will not disturb anything. It will let it continue and again it will executing one more block. Right? Then here this is also sending the same way. Block is completed in the first heartbeat signal, it is completed 20% and again it is completed 50% and again it is completed 85%. Again it is 85%, again it is 85%. That means this is also still executing blocking. Then job tracker what will do? It will start one more execution in the third block of data also. How many replications are there? Those many times it will start. Now parallelly 3 processes are executing on same block, duplicate data, right? Same block of data. Then it will wait which one will complete first, then it will take that particular output. Which one, suppose while it is executing 85, it is started, now just it is sending 20% is completed. By that time, it may complete 90% and again it may complete 100% also. Something, maybe some memory related things release completed. Again it is sending the output to here, then immediately it will kill these two. It will take the only this one. Okay. Suppose if it is executed at 90%, again it may complete 100% successfully. That means then it will take the output from this second one and it will kill these two. This is called speculative execution. Got it? When process is not, almost all tasks are completed, only one, maybe 1 or 2 tasks are still executing. At this time, at this point of time, we can apply speculative execution process. Okay.
Okay.
Yeah. Any doubt?
No.
Anyone? Clear it? Yes, Sadesh, Jankiram, Sai. So this is important point. Most of the interviews they'll ask this question. Task attempt, task fail, task kill, task speculative execution. Okay, what is job? What is task attempt? There may be the in terminology. We need to use this terminology mostly at the time of working. Next is the input split. Input split is nothing but taking the data on particular data into small blocks. So by default, the block of data is nothing but some portion of data, right? So in Mapreduce terminology, we will call it as a input split. But in HDFS, we'll call it as a block of data, right? Always block of data is equal to input split. Block equal to input split. So we'll call block in HDFS, we'll call input split in Mapreduce. In HDFS, we'll call, but in Mapreduce we'll call like this. Both are same, almost. Yeah. The portion of data or chunk of data on which mapper operates is called a input split. The storing in the HDFS is a block, and the taking that block of data and executing is called a input split. How much data is taking mapper as an input, that means called as a input split. Okay. Input split is just a reference of data. Default input split size equal to block size always by default. But there is a chances to change it also, I will tell you. Okay, suppose 128 MB of data is there in the HDFS we are copying. By default 64 MB is the block size, right? Simply it will split into 2 blocks and store into the HDFS. There are 2 blocks of data. That means there will be 2 input splits like that. Only terminology is changing and internal data is same size. So each mapper works only on one input split. That means 1 block of data, right? So when we are when we are splitting the data into a small parts, then it will be increasing the performance, right? If you, instead of working one block, say 128 MB data, if you split into 64 MB, then obviously the performance will be increased, right? Correct? Suppose you have a data here, just suppose you have a data of 1 GB data is there. This 1 GB data, if you are storing then as a 64 MB, then it will be approximately 15 to 16 blocks will be there, right? 16 blocks will be there. So suppose instead of using, when you are using 64 MB as a split size, block size, but when you are using 128 MB block size, then how many? Approximately 8 blocks will be there. So if you are using like this, then in this situation 8 mappers will work. But here in this situation 15 mappers will work, right? Suppose each mapper is taking to execute the data. So 128 MB of data, it is taking approximately 2 minutes time. 128 MB of data, 2 minutes time for each mapper. Then how much time it will take? 8 into 2 minutes, approximately 16 minutes it will take, right, to complete the particular one. But here, the same way, if you are using the data, we are not changing anything, just we have changed the block size, then 15 blocks will be there and 15 mappers will execute. When 15 mappers are executing, this is 64 MB only, right? Then only it will take 1 minute time, right? But the time will be decreased. 15 mappers are executing parallel instead of 8 mappers are executing. That means it will take half of the time. That means it will be just complete by 8 minutes process. Got it? When it is taking 128 MB of 2 minutes, then it will take only 1 minute time. But here we are not using 8 mappers, we are using 15 mappers, then 50% time will be reduced. So this is how the blocks and dividing the portion of blocks will be useful. But here one more challenge is, already we have stored the data with 128 MB in the HDFS, but we cannot change the block size, right, once you copy. But in this situation, still I want to execute mapper on less amount of data. Then there is an option to change the input split irrespective of the block size also. Okay, so general input split is equal to block size, which is 64 MB, but if I want to work the mapper on top of only 32 MB, not 64 MB, I want to increase the performance, I want to execute the data within the less time, then we cannot change the block size, but we can change the input split size by using below properties. Okay. I will tell you, we need to take one example and I'll explain it. How can exactly we change the split size? What is the use in the real time to changing the split size? Okay. So as of now, clear, right? Still here. Today we have discussed what is the Mapreduce framework, what exactly mapper, what is reducer, and what is the 5 typical phases. Mapper, partition, sorting, shuffling we did not talk, we'll talk. Reducer, and what is the job, task attempt, task failed, and a killed task, changing the maximum attempts for mapper and reducer, and input split and speculative execution. So these are the approximately 7 to 8, 10 different points we have discussed. So any doubt on these things? Clear, right? Okay. Thanks, Sharon. Tomorrow we'll talk about when exactly we'll split the data, input split, and what is the advantage, what is the this one particular algorithm is there, how it will work with that algorithm we'll discuss. Maybe next 2 sessions will be a little theoretical. You need to concentrate a little more. So, but a very important points these are. Okay, the Mapreduce is the base for all execution engines, even for Hive or Pig or Spark or any other thing also it's important. Okay, so tomorrow we'll continue from here. Okay, if we don't have any doubts, we can conclude the session. Okay, yeah. Okay, then thank you. We'll meet tomorrow. Bye.
Thanks.
Good night. Thanks, Sahil. Bye.